Hello guys and welcome to another video on Microbit Pomodoro project. We are going to implement a new feature to display LEDs according to the time that is left in our timer. Let's say that we start with 25 minutes for the work phase. All LEDs should be lit up. After 1 minute, because there are 25 LEDs, only 24 LEDs should remain lit up and the last one should be turned off. And we are going to turn off them starting from the bottom right, going to the left, and then going one row above and turning them off until we turn them off, all of them. And in the next phase, it will repeat the cycle, but it will be faster because we have only 5 minutes in the break phase. Let's rearrange these blocks a little bit. We will create a new function called displayLeds, and let's call this function displayLeds right after we decrement our timer value. So what is our strategy going to be? We are going to iterate over all rows and over all columns. For that, we can use for loop, and actually we can use two for loops that are nested, and let's create two new variables, variable row and variable column. And I like to start from row, then column. In the first iteration, row will be 0, then we go over all the columns from the 0th row, so it will go like this, 0, 0, 0, 1, and so on. Now let's try to light up all LEDs. For that we can use this block. There is plot that is going to turn the LED on, and unplot is going to turn the LED off. We are going to use plot, and let's choose some LED to turn it on. 0, 0 is not a good example to show you what I mean, because we need to figure out what is X and what is Y value. So if we provide different indexes, like if we say X is 2 and we keep Y as 0, clearly we can see that we have a row with index 0 and column with index 2. And this means that we are going to use this function with column first, then row. So we need to provide column. If you don't provide row, it will stay the same, so it will be 0 all the time, which means that we are going to light up only those LEDs that are on the row 0. But let's use a row here, and this will light up all of them. Now, instead of turning them all on, we want to calculate which LEDs we should turn on. Let's use if block, and if some condition, okay, let me rearrange it. If some condition is true, we are going to light them up. Otherwise, we are going to turn them off. We are going to use same column and row. And for this evaluation of the if block, we are going to create a new function, and let's name it shouldPlot. This function will accept two parameters. The first one is row, and the second one is column. We want to return some evaluation from this function, so we can go here in functions and take return. Let's say for now that we want to return, let's say that we want to, let's put this comparison, and let's say Okay, let's say if row is by index 2, this will be true, otherwise it will be false. Now we can simply use the call to this function here, and we need to provide row and column. Have row and column. Let's inspect now. So row by index 2 will have LEDs light up. That's great. Now the only thing that we need to change is to calculate which LED should be, by which condition LED should be light on. Let's think for a second about how these LEDs are going to be turned on or off. We have 25 of them, and as time passes by, they should turn off one by one, starting from the bottom right. That means there is a minimum amount of time for the timer for every LED to be turned on. And we can calculate what is that minimum amount of time for the current LED, because we are iterating over all of them, and compare that time, that minimum time for the LED to be turned on with current timer value. And it will show us if the current time is enough to keep this LED turned on. Let's create a new variable called ledIndex, and we want to set ledIndex. We want to calculate its position in this array, starting from 0 all the way to 24. So we need to multiply row index by 5 and add column to it. So it will go 0, 1, 2, 3, 4. For the row 1, it will be 5 plus 0 for the zeroth column. So it will just continue 5, 6, 7, 8, and so on. So we need two math operators. We need to multiply, and we need to add. But we need to reverse the order, so I can just do it like this. I can say multiply row by 5 and add the column. So just to repeat this once more, we are going to iterate over rows and columns, and for each LED that we are inspecting, should it be plotted or not, we are going to calculate first the LED index, which is going to be row times 5 plus column. It will give us the range from 0 to 24, 0, 1, 2, 3, 4, 5, and so on. Now that we have that index, it's easy to come up with the time value that is needed for this LED to be turned on. And let's call this variable ledMinimum. We can say ledMinActiveTime. And we want to set it to some value. We want to see the fraction of this index to the total time that is that our timer is going to count. But we don't know what is the total time, because we have two phases. We have work phase and we have break phase. So we need another variable that is called total time, and we are going to set this total time to some value, and it needs to be conditional. So let's put if block. It's not working like that. So let's try to, oops. Yeah, we can put it like here, and we can say set total time to work time. if the condition that needs to be set to true is this one. If we are in the work phase, then total time is work time. Otherwise, total time is break time. Now we have the total time and we need to take a fraction of that total time based on this LED index. To do that, we need math operator again. We want to multiply LED index by total time. And we want to divide it by 25 because the total number of LEDs is 25. And this should give us LED minimum active time. Now we want to compare this. We want to see if the timer value is greater than LED minimum active time. Now it seems that everything is working just fine, but to test this a bit quicker, let's reduce the work time to 1 minute, and we should see LEDs should be turned off more quickly because we should see then 25 of them should be turned off in a matter of 1 minute. So this is a reasonable speed, and I will just remove this. I will revert this back to 25 minutes. And that's all for this video. I hope that you enjoyed it and see you in the next one. Bye bye.